Next up, we have our usual MC, Mark Bennett, up to talk. He's going to be talking about functional reactive applications, whatever that means. So Mark, I'll invite you to the front here to teach us all about that.
All right, hello everybody. Can you all hear me okay? Yes. Yeah, okay. I guess if you can't hear me, you won't know I asked that question, so it won't matter. Yeah, so like Sean said, we're here to talk about functional reactive applications. So I know that's kind of just a blob of words there, so I'm going to start by kind of breaking that down a bit. I'll talk about why you might care about that, and then we'll get into the nitty-gritty of what that really means and how you might go about using it. My goal today is not to use slides, so all of my notes and stuff like that are in my GitHub repo too, and it's all old-fashioned ASCII art. But if you're having trouble reading anything, just let me know. There's lots of words you're going to see in the notes here that you don't have to read right now. They're more if you decide to check it out later and want to kind of follow along with the details. They'll explain everything in detail I'm not going to do now. All right, make sure I got my timer. Okay, so for the sake of this demo, we're going to talk about a functional reactive application as three things. First of all, it's made up of something called pure functions. It also reacts asynchronously to changing data and events in the application. And finally, it receives input from outside of the application and in the form usually of events, and then it's going to generate some output from that. So I'll talk more about what those mean later. But yeah, for now, just remember pure functions, reacts asynchronously, and receives input and produces output. And because of those properties, there's a couple benefits that we get from using functional reactive architectures that are really useful, especially when it comes to things like testing and just reasoning about your code. Because they're all pure functions. One of the things you'll see with that is that the functions don't have any side effects. So they're really easy to test because you just test the inputs or generate the inputs, test the outputs, and you know they'll behave properly. FPA is also interesting because it's something that is moving more and more into a lot of popular frameworks that we use regularly. So things like React and Redux are arguably FPA. Angular 2 uses observables quite a bit, so a lot of that ties into what we'll talk about today. Vue, Elm, things like that. And the other thing too is that functional reactive applications are also really well suited to work with asynchronous code that you see a lot in complicated GUIs, networked environments, things like that, like you have in a web page. So I'll quickly just walk through this. The big thing to know is that pure functions, and I apologize to any of you that have a computer science or computer engineering backgrounds. I'm going to kind of summarize this a little bit. But basically, for the sake of this, a pure function is a function that doesn't have any side effects. And what that means is here, let's say we have a state that we've declared in our application, and then we have a change state function that we're going to call. And the way it works is by reaching out into the rest of the application's environment and modifying that state. So what we're saying there is that the function has behavior outside of just its inputs and outputs. In this case, it doesn't have any inputs, it doesn't have any output. So it's, in terms of testing it and things like that, you have to set up the whole environment that it runs in. It just makes it a little more complicated to use and to reason about. The pure version of that is not much more complicated, but basically what we do is we're going to go, and when we call the function, we're going to pass in that state, and at the end of it, we're going to return a fresh copy of it. And we're being a bit idiomatic here in returning a new copy. You'll see code in a lot of JavaScript especially where it's not optimized for making quick copies and handling those well in memory. So you'll see there's a little bit of kind of things in JavaScript where you will actually modify existing state and then return that. But if we want to be technically pure, really you should make copies of things, returning new copies that you can test against. So there we go. That's really all I need to know. Is a pure function is one that doesn't have any side effects outside its input and output. So the other thing that you need to understand here, I don't know why I'm scrolling oddly, but sorry about that, is that it reacts asynchronously. And so you'll hear about things like React and stuff like that. That's actually kind of where they get their name from. And the idea is that you have events and changes in your data that come into the application, and the application then responds to those changes and propagates them throughout the rest of the application on its own. So rather than, let's say, reaching out into the environment and pulling data in, you're going to have things from UI and network that are pushing things into your application. So that's the reactive essence of it. There's a few different libraries and tools that you can use to do that. For this demo, we're going to be using a lot of RxJS and Observables, which I know Essen kind of alluded to there a little bit in their code too. You could also use callbacks or generators. A lot of these ideas would apply to those as well. I'm just using Observables because I find them pretty easy to reason about and to work with. In terms of understanding them, we actually had a talk a little while ago about observables, so hopefully you saw that. If you didn't, the big things that you need to take away is an observable is sort of like an array or an iterable, but the big thing is that it has a sense of timing too. So when it emits values out of it, they're going to be pushed, and there's a sense of like one comes after the other after the other. And so the operators and tools that you use around those are aware of that, and they can do things like throttle, debounce. They can do all sorts of things where, if you have a new value that comes in after a certain time, it'll replace an old value, things like that. So yeah, basically you can almost think about them as iterables that are aware of time. In terms of the architecture that I'm going to put forward here for functional reactive application, there's a couple different ways you can do it, but one of the things that I found when I was first starting to write applications like this is that it was good to have a simple mental model in your head in terms of how you decompose your application. Otherwise, you end up with a lot of spaghetti code where you have things coming in from the external environment, mixing with your model and mixing with your rendering. And what I like to do is kind of separate those into 3 separate concerns. So if you're used to something like model view controller or other kind of patterns like that, you could think of this as model view intent, or I guess it's more intent model view. And so the idea is that you get these intents, these changes in data or events coming in from outside the system. They are passed to the model that updates the state, and then the state is then pushed out to the view, which does the rendering. And so one of the interesting things with this is that there's no kind of backwards channel that they come in. So when you render your view, that's going to be exposed to the browser or the operating system, and all of the side effects are going to happen outside your application. So if you start a request or something like that, you'll see the reply maybe come back in from the operating system as an intent. If a user is doing something, if you've generated a list or something, the changes that they want to make will come back in as an intent to edit an item or add an item, things like that. So yeah, basically this is the flow that we're going to explore a bit in here, and I'll break it down and go through each of the parts and see how you can use those in another application. In terms of the architecture too, there are a bunch of tools that kind of formalize this and take this idea and standardize it a bit. I did a survey about a month and a half ago just trying to figure out what people wanted, and the sense that I got from people is that they didn't want me to focus too much on those. So for the sake of this, I'm just going to use vanilla JavaScript, and the only addition is going to be that RxJS library. But ideally that means you can take a lot of what I do and use it with Angular 2, you could use it with React Observable, things like that. Vue.js has a pretty good binding now for observables and stuff like that too. So hopefully you'll be able to get something out of this regardless of what you're using. Oh, and the one other thing too, that this still kind of confuses me a little bit now, but typically when you see Vue, you think of the HTML and the DOM that comes out of your application. But one of the first things that you really have to start to think about differently is the idea that stuff like network requests and those kind of things can actually be part of your view. And so your application would render those to the environment. The environment would go process those in kind of a declarative way, you could almost think of it as. So you could say, right now my application has an ongoing request for this resource. And then outside your application, you have something that handles that. And when that resource is available, it will kick a new intent back in. Sort of like how events are fired from DOM elements and stuff like that. And if you are following along either on your laptops here or at home, the repo for all of this is github.com/markbennett/FRP architecture. So that's also, I guess, if you want to follow on YouTube later, you can pause the video now and pull that up. And because we don't have a ton of time, I'm just going to ask that people save questions to the end. Okay, so I'm going to scroll by these pretty quickly. These are just some constants. You can see we're declaring different kinds of intents, some constants we'll use later for keyboard mapping, and also an initial state for our application. So, not too much to see there. Now this is probably the body, and what I think is one of the really interesting parts of this architecture, because what you can do is we declare something called the reducer. And basically what the reducer does, it takes in the current state, it takes in an intent, and figures out, given the current state, how do I have to modify it to reflect the intent. So we have intents for all sorts of things that we're going to do. And today we're going to be using a fairly classic example that I think most people understand. It's the to-do app, and I've actually taken this app from, there's a site called To-Do MVC that implements to-dos and a bunch of different things. So they have great scaffolding for this, so I've just used that. I'll give you a quick rundown of how it works. Basically, you type in something new up here, shows up down there. You can check it or uncheck it. You can clear the completed ones, and if I do it right, you can double click to edit a task, like that. So that's what we're gonna kind of build today. So what happens is whenever I'm doing those changes in my application, I'm actually producing intents that are coming into this reducer function. So we have a little thing here where we go look at the kind of intent it was, make any changes to the state that we need to do, returning a new copy, or at least we should be, and then return that state. So the new state is what comes out of this function at the end. So I won't go through all those. You can see basically we have a case for everyone. And if we get something that we don't recognize as a known intent, I just have a default one that returns the current state. It's kind of just a no-op thing. So for rendering, it was actually probably 80% of this code base was doing the rendering. I'm not going to go through all the details of it. Basically what happens is it takes in the state, produces a tree of DOM elements, and then to make it a little more performant, I'm using a separate library that just does that virtual DOM kind of patching, where it looks at the current DOM, has this new DOM that's generated, and just changes the differences between them. But what I would like to show in here is how we're actually wiring it up to pull the intents out of the user interface. So up here, for example, we have, I call this the new to-do. And when you're typing here, it's generating key press events. So, hello. And what's happening is in here, if I set a breakpoint here, oh, why is it not letting me set a breakpoint? Okay, 1 second. There we go. Okay. Yeah, okay, great. So what's happening is we have one of these streams of events. And so right here we have a new to-do key press. Oh, sorry. Okay. We have a stream of key press events. What we're going to do is we're going to take those, and that stream is actually an observable. So it's emitting key presses over time. And every time it does that, what we're going to do is take those and convert them into an intent, into one of these little actions. And then that becomes this new stream of observable values called the new to-do edits. So here, when you're typing, what you're seeing is basically just little values coming through. And the payload is going to be the value of that form field at any given moment. So if you're used to using React or those kind of frameworks, you're probably pretty familiar with this model. And then down here, what's interesting is that I take this stream of these actions and zip all the way down to the bottom, where we might manage the intents in the application. I'm just going to hide this so you guys can see a little bit more. Can I do that? Oh, let me do that while it's running. Okay. So down here, what we have is we're going to go and collect all of those streams of intents, all of these streams of values, and we're going to use something called a merge to gather them together into one large stream of intents. And what that's going to be is basically the stream of the values that we're going to pass back into that reducer every time. So these intents down here, one of the things I like about it is it's super straightforward and clear to see, when I have an action that's coming in my system, it was coming from, like, if it's a to-do edit, it's coming from this new to-do stream that's defined, like, you can just look for the reference and it's defined up here in your code. It's super clear how they're being generated, where they're coming from. And you can actually go and put breakpoints or logging in all of these different parts of the application and clearly see how the behavior in your application is composing. So the other thing I want to show you too is that, like, right now we've just shown how you can take a value and map it to a new value. But there's all sorts of other operators that you can use on these to modify that stream that's produced. So one of the things I do here is I'm going to go and make a stream of intents to create new to-dos from the key presses coming off that form field. But the interesting thing is I only want to make a new to-do when they press enter. So here I've got that stream of click event or of key press events coming off the form field. I'm going to filter it and check the key press basically value to see if it's an enter. And if it is, then I'm going to carry on and then map that to a to-do create, and that will put it in the list down below. So does that kind of make sense to people, how we're basically using these event streams to turn them into the business logic and into these intents, which we then feed into the model to produce the new state? It does get a bit more complicated for other parts when we have more complicated ones. I'm just trying to think if there's any ones. Yeah, so down here, this is about as advanced I'm going to get in this demo. But things like map and filter you would see on an iterable, like an array or something like that. Where it gets interesting with observables is when you actually start to use operators that have a sense of time. So normally I would use a double click event here to go and map things so that I could detect the double clicks on that form field when you edit something. But I don't have to do that. What I'm actually doing here is I have a stream of click events coming off each one of these form fields. And when you click on them, I go and I buffer up those values over 350 milliseconds into a little array, basically. And then I count the length of that array. And if it's more than 2, I know you've double clicked. And then I map that into a click that'll switch it from just the kind of view mode into the changed edit task mode. Like that. So, like, the cool thing there is, let's say I find out that I'm a bit slow to type and I really like to use triple clicks for some reason. I can go ahead and do that. And now let's see if I can do a triple click on the keyboard. No. Yeah, there we go. Yeah, so you can see now it's actually like triple clicks it's detecting instead of doubles. So I mean, I don't know from this applications perspective, I don't know if there's a real use in doing that, but the idea that you can go and start to work with values over time is very useful, especially as you start to get into things like animations or more complicated networked applications, stuff like that. Let's hide this guy if I can. Escape. There we go. So I'll jump through the rest of the code here. That was the big thing I wanted you guys to see, is how we're turning those events into streams and then mapping the stream of events from the DOM into intents. Down here, the other cool thing that you see is I've actually got quite a few different places in my application that are emitting change events for my to-dos. I use them whenever you check something is completed, whenever you start or stop editing, or when you actually change the description itself. And so I'm actually going and using a set of different event stream or intent streams and merging those into one, which I'm actually then using down here in the model. So it's a useful way to kind of take more complicated things like that and break them down a little bit so you can reason with them a little bit more. Finally, the magic that wires it all up is right here. So basically what I do to get the state, I have the set of intents, I start it with the initial state, and then I use this function called scan. And scan is something that you'll see on observables that basically goes, and it's useful for taking a set of things and producing an output from them. But the cool thing is that it goes and it passes in the last value every time it's called as well. So when I call the reducer, it's going to return that state. And the next time that scan gets called, it's going to pass in the action as well as the previous state from the last time it was called. So it's sort of like if you use, what is it called? There's scan. I'm just thinking about Ruby now. If you use reduce, it's similar to that if you used to reduce it before. Or inject, exactly. So, so that's what I'm doing to get the state. And so now my state is actually another observable. And every time it emits, it's going to emit a new state that the renderer is going to go and actually receive that whole state, render it out, and then I'll use that code to patch the DOM with the changes. So I'm just about out of time here. I'm just going to quickly wrap up. So in conclusion, the big things that I like about functional reactive applications is that they're a reliable and testable way to handle complex asynchronous code. There's a couple cases I didn't cover here where you're doing things like making a network request, but really what you do there is you just have an intent to start it and another intent that would stop it or update progress or cancel it, things like that. So you just kind of think about breaking it down into multiple intents rather than just one. And if you're interested, I've got a whole list of resources there that you should definitely check out if you want to learn more. Also, just a quick shout out to Ben Less, Andre Saltz, and Rudy Yardley, who all had really helpful articles and feedback on this. And To Do MVC, because their scaffolding was great and it made the To Do part of this a lot easier to put together. So with that, I'll attempt to answer questions. Ben.
I got a few. I'm just trying to think which ones first. What motivated you to build an FRP from scratch?
Well, so originally I was either going to do it in React or in Cycle, which are the two frameworks I would actually usually use in applications. But for the sake of kind of reaching the broadest argument, I tried, and also just kind of as a test, I tried to break it down and just use RX instead. Because one of the things too is that RX itself right now is kind of informing the standardization process around observables. So the idea is that over the next couple of years, observables are going to move into the browser too. And so a lot of what you're seeing right now with the RX library, you wouldn't actually need to include a library to do. You could just do it in the browser, which is nice. But that's kind of moving along. It just moves at the pace of standards. So yeah, to answer your question, I don't know if I would actually do it with just RX in the future. There's a couple things that I didn't like about this that I had to kind of manually handle myself that you would get from those frameworks. But if you were interested in it, there's Redux Observable is a good way to use observables with React. I haven't used that one too much myself. I have mostly used Cycle for my apps. The other thing I haven't talked about too much, because it's fairly framework specific, is you can break your application down usually into components. So one of the things you'll see is that if you have a set of intents coming in, you'll pass that along with a state to a component, and then maybe that'll output and just target like a chunk of the DOM or something like that. And so a lot of these frameworks have some ability to do that and pass a component through your application too, which is a nice way to break down stuff. So. Any other questions? You can go again if you want. Right there.
I thought it was really interesting how you basically had one stream of events that you were using filters and maps turn into different intents.
Yeah.
So maybe if actually you could scroll up to particularly the one in the new to-do description where you had both the actual just content as well as the enter key press.
Oh sure, like up here the new key press one? Yeah, where is that? There we go, right here.
Yeah, so there's both new to-do edit and to-dos create, which are both being derived from new to-do, the new to-do key press observable.
Right.
Is it deterministic what sequence those are going to occur in?
So it depends. It depends on the implementation you're using. So right now in the spec, I think that's some of the stuff they're still trying to figure out. RX has this really cool idea of something called a scheduler. And so basically you can, when you do any of these calls, like when I made the subject here, or when I do the mapping even, you can inject a scheduler in. And so they have schedulers that are synchronous, which is useful for testing, asynchronous. There's ones that tie into request animation frame and stuff. So RX is kind of neat that way in that you can tell that it's it's on version 5 now, and you can tell that people have used it in production for a long time because of stuff like that. Now I don't know if or when those will make it in the spec and like in what form, but in terms of how these are called, one of the I guess the useful things about this is that for our purposes it shouldn't matter, right? So if we're actually using immutable state and all that kind of stuff, it shouldn't matter who's called first there. In practice, I haven't had any issues really with that, and I'd like to think it's just because it's triggering them in the right order. I don't know. I'm not sure, but it hasn't been an issue practically for me in testing this. Actually, that's one other thing I'll mention too is there's a library called Immutable.js. I'm not a huge fan of it because it adds a lot of like API cruft, I think, a bit. But it is really useful if you're working with a lot of immutable data structures where you're going to be making copies of them and passing them around a lot. It can do a lot to help with performance and memory. So if you're doing a lot of this, most people end up using it at some point. So you would be doing yourself a favor to at least take a look at Immutable.js, even if it's just to decide you don't want to use it.
There's also a tiny piece of React called immutability helpers that you can use on its own.
I didn't know that.
And it makes it, the syntax is a little weird at first, but you can like update part of a deeply nested object and get a completely new object back.
Well, and correct me if I'm wrong, but isn't this the kind of thing that TypeScript could help with? Like you can have read-only things and stuff like that?
Not specifically immutability though, because you need that to be a runtime check, right?
Right.
So there are a couple libraries that try to do it, but I haven't found them. Like we're doing the React app or now we're using Immutable, and I don't really like it. But
yeah. Okay.
like, like you're saying, it just makes things weird, right? It's just a button prop. But yeah, we couldn't find any solution that TypeScript would provide.
Yeah, I'm surprised there hasn't been any talk of like immutable types built into the browsers yet.
There is a GitHub issue on the TypeScript thing, but basically it's well down the roadmap.
Yeah, for sure. Okay, great. Were there any other questions? I'll post that link to my repo too if you want to check it out. Yeah.
So I was wondering if you could maybe just talk a little bit about these handlers. So you have like the new to-do report key press handler, and then with like the .next.
Yeah, so basically what this here is, now this was probably the clunkiest part of this app that I didn't like. When I'm working with cycle or things like that, you can basically just declare a selector and an event, and it will go and produce an observable string for you. With this, the way the virtual DOM library I was working with worked, you have to pass like a handler in that can get registered and removed, and the virtual DOM handles that for you. So basically I had to have these handlers, and all they do is produce these observables for me. I'm sure if I knew this was my first time using SnapDOM, which is the virtual DOM library, I'm sure there's probably a way I could have done it, but I don't know. Sean's raising his hand.
Did you start with SnapDOM, or did you add it after you actually had performance issues?
I just started with SnapDOM. I kind of wanted an excuse to use it, and so I'd heard of it before, and I wanted to check it out. It actually, honestly, it has a super minimal API, and it seemed really performant, and it did. I think the only thing I ran into issues with was this thing with observables, and I'm pretty sure it was like a user error rather than a library author error.
I think the DOM itself is getting faster, especially the way you can actually subscribe to browser events. So I was curious if it was strictly necessary or more just interesting.
I think probably just more interesting, but it seemed like all the other frameworks that are doing this kind of one-way data flow have decided they have to do that, so I just figured I would try and write it myself too.
Right, so the dot, I'm trying to, we were talking about. So the new to-do key press is a subject, and the dot next is like publishing that as the next.
Yeah, exactly. So basically a subject is like an observable that you can also publish things to. Right. So it's like an easy way to make an observable when you don't have one.
Subscriber kind of.
Yeah, it's both an observable and like a subscriber kind of.
Yeah.
So. Yeah, I don't think you're really supposed to use them as much as I did in this demo. So I guess if that's one takeaway, don't use subjects like I did. Yeah.
I think that this will probably be answered by the fact that this library is what you're using, but when I've gone to do similar patterns, so we have some components that have like state that gets pushed down, and you have to send it doesn't use the the pattern of events flowing here, but it uses the general idea of you like push your state out to the top. It comes back, and no matter what is setting the state, you get the same DOM out of it.
Right.
So one of the things I found building that, or a lesson I quickly learned was that like the inputs, because you're like, as you hit a key, the value, you're sending that key press actually out to the top and back into the input.
Right.
When I first built it, and I was playing with like what the rendering technique should be, because I was re-rendering a new input every time, I was like losing my focus.
Right.
Because it was removing and adding like a new input field.
Yeah.
So as I evolved the technique, I made it so it just, like certain parts of the update are just attribute updates, and some parts of the update are actually new DOM.
Right.
And I kind of stayed away from using like libraries that kind of magically handle that for you, but I'm just wondering if you hit some quirks like that.
You know what? I thought I would hit some quirks because that is definitely like React has kind of affordances in its API for handling forms. A lot of those kind of libraries do, and I assumed I would, but I didn't. Like I don't exactly know how that is working in SAP, but like no, I seriously like so because when I'm typing here, I thought, oh yeah, I'm gonna have like some delay, and it's gonna like delay and like update back a character or something. I don't know if it's just a tight enough loop right now that I haven't seen that, and maybe if the application was bigger, I would have issues. But for whatever reason, it did not seem like that was an issue.
I like how the other libraries do solve this. Essentially, that's that they try to be clever. So they won't replace your input. Like they'll just update attributes as much as possible. And avoid taking something out of the DOM, putting it back in. That helps that situation a lot with weird delays and so forth.
Well, I know too that this isn't replacing the elements every time it does an update because it's doing the patch, but I don't know exactly how it's handling updating that. And I think there must be some logic in the browser too that like if you're editing something and someone also changes the property, there must be some logic there about who kind of wins in that situation. So yeah. Anyway, I didn't run into it. I kind of just thanked myself that I didn't move it on.
The libraries probably like solve that problem for you and hundreds of other people.
Yeah, for sure. Well, I think maybe I'll wrap this up here. I'm going to be going down for drinks, so if you have more questions, you can hit me up there. You can also find me on GitHub or Twitter at Mark Bennett, and I'm always happy to take questions and comments. So thank you.
Thanks, Mike.